Hello, everybody, and welcome to Lesson 5 of our Angles and Ratios trig unit. So today we are looking at special triangles and exact values. So in this lesson, we will determine the exact value of the sine, cos, and tan ratio for a given angle with a reference angle of 0, 30, 45, 60, and 90. So we're going to develop a quick strategy on figuring out the ratios with those reference angles. So it's going to require a little bit of an investigation to start, but it won't take us too long. So we're going to look at part A for right now. It shows us a triangle with 45-degree reference angle where each of the A and B sides are 1, and they want us to find the hypotenuse, or the C. So we know that c squared is equal to a squared plus b squared. That's Pythag, right? Our Pythagorean theorem. And so we can determine the length of our hypotenuse just by saying, I think we used earlier in the unit, just so that I don't mess you up, we used r squared is equal to x squared plus y squared as well, because r would represent the radius. So in this case, we can say r squared is equal to 1 squared plus 1 squared. So r squared is equal to 2. 1 squared is 1 plus 1 squared is 1, which gives us 2. So that means we know that r is root 2. So if this is 1, and that's root 2, then we know sine of 45, which is y over r. So sine of 45 is going to equal 1 over root 2. Cos is x over r. So cos of 45 will be 1 over root 2. Both of these, 1 over root 2, can be written. Let me just move this over so that we have some space. Because if you remember from our radicals unit, we don't really love having our square root on the bottom. So if we want to rationalize this, we can multiply both top and bottom by root 2, and that gives us root 2 over 2. So we can rewrite that as root 2 over 2 for both of them. And then tan is going to be y over x. So our tan ratio for 45 is going to be 1 over 1, or that's just equal to 1. So these are specific ratios that represent the sine, cos, and tan. The sine, cos, and tan ratio of 45 degrees. Sorry. All right, so here we go. Diagram 2 shows an angle of 60 degrees in standard position, and an equilateral triangle is drawn whose sides are 2 units, and the vertical altitude is drawn. That's this line here, which divides it into 2 and gives us a right angle triangle. So if this was an equilateral triangle, that means this whole side was also equal to 2. So if I split it in half, that means that this length is 1, that length is 2, and we want to find the y value here. So in this case, we know r squared is equal to x squared plus y squared, but using algebra, we can flip that around to be y squared is equal to r squared minus x squared. So y squared is equal to 2 squared minus 1 squared, which is 4 minus 1, which is 3, and then we can square root both sides. So we get y is equal to root 3. And we can create our ratios for sine, cos, and tan of 60 degrees. So we know that sine is going to be y over r. So sine of 60 is going to be root 3 over 2. Cos of 60 is x over r. So that's going to be 1 over root 3. And tan of 60 is y over x. So tan of 60 is going to be root 3 over 1. But if it's just over 1, we can say it's root 3. So one more, it's going to be the same triangle as above, but it's flipped on its side. So that means that this side is 1, and instead of doing all the work, we know that if this one's 2 and this one's 1, this one is going to be root 3. So things are a little bit different now. Our x and our y have been swapped. So you can see in the top one, x was 1 and y was root 3, and now x is root 3 and y is 1. So our sine, cos, and tan ratios are going to be a little bit different. So in this case, sine, which we know as y over r, is going to be 1/2. Cos, which is x over r, is going to be root 3 over 2. And, oh, did I mess up the top one? I did mess up the top one. Here we go. That is not right. I apologize. That should be 2. R is 2. You can see these two switch. Okay, hopefully you caught that. But if not, pay more attention or something. This is your fault. I blame you. Just kidding. Totally my fault. Tan of 30. So tan is y over x. So that's 1 over root 3. And again, we don't often like to have square roots in the bottom, so we can rationalize because we all know how to do that now. And that gives us root 3 over 3. Yay! So these are our special triangles, ones that we have to remember and know. And you can see here they've got them all drawn here. So what they've done is they've reduced all of the radiuses to a value of 1. So how they would do that is, well, to get 2 to 1, we would divide by 2, and all of these have to divide by 2. And you can see that that becomes 3 over 2 and 1 over 2. Same thing in this case, we're going to divide by root 2. So we divide by root 2, divide by root 2, and this is rationalized, and this is also rationalized. And same thing over here, divide by 2, divide by 2. So now we have our special triangles. That's way too big. Hang on. Our special triangles here with a radius of 1 in all of them. So when that's the case, then we can use that to fill out our little table here for 30, 45, and 60. We know that sine is going to be sine of 30. So we know sine is going to be y over r. So sine of 30 is going to be 1.5. So this is y, x, and r. If r is just 1, and you divide anything by 1, then it's just going to end up being the y value here, right? Because y divided by 1 is just y. So that's 1/2. 45 is the same way. It's going to be root 2 over 2. And 60 is going to be root 3 over 2. So it's all the y values here, because the r value is 1, and when we divide by 1, it doesn't change the value. So these are just the y values. The cos is just the x values, because again, we're dividing by 1. Cos is x over r is 1. So it just ends up being the x values. So cos of 30 is root 3 over 2. Cos of 45 is root 2 over 2. And cos of 60 is 1/2. So you can see they are the same values but flipped. So if sine of 30 is 1/2, cos of 60 is 1/2. Sine of 60 is root 3 over 2, cos of 30 is root 3 over 2. And then tan's interesting. So tan is always the x divided by the y. Let's see if I can zoom in here. It's x divided by y of these special triangles. So if that's the case, our tan is going to be 1 over root 3, or we can rationalize that to be root 3 over 3. 45, you can see they're the same. Root 2 over 2, root 2 over 2. So if we divide that, we get 1. And tan of 60 is going to be root 3 over 2 divided by 1 over 2, and that ends up just giving us root 3. So finding the exact trigonomic ratios for angles 0 to 90. So consider a rotation angle of 0 degrees. In this case, x is 1, y is 0, r is 1. So if we're looking at this, we're looking at if this value is 1 and our y value is 0, right? X is 1, y is 0. It still makes r 1 because we do have sine values, cos values, and tan values of 0. So these are they still have to have values. So we know sine is y over r. In this case, y is 0, r is 1. So sine of 0 is just going to give us 0. Cos of 0 is x over r. So x is 1, y is 1. 1 over 1 gives us 1. So cos of 0 is 1. It's not just 0, which seems like it would make sense, but cos is a little bit different than tan. Or cos is different than sine, sorry. And tan is y over x, so 0 over 1, and that gives us a value of 0. So these are also part of our special triangles, right? We want to find 0, 30, 45, 60, and 90. So here we're doing 0 and 90. Up here we did 30, 45, and 60. All right, same thing. We have sine of 90 now. So now we're looking at if x is 0, y is 1, and that would make r1 as well. Sine of 90, x over r. X is 0. Sorry, that's a lie. Sine is y over r. So 1 over 1 gives us 1. So sine of 90 is equal to 1. Cos of 90 is x over r. In this case, x is 0, r is 1, so we get 0. And tan of 90 is very interesting. Y over x. Y is 1, x is 0. And if you divide anything by 0, we get undefined. So explain why tan of 90 is undefined. Well, you can't divide by 0. Division by 0 is undefined. You get an error on your calculator. All right. So there are two different ways to do these without technology to solve these, to find the exact value of sine, cos, and tan with a reference angle of 0, 30, 45, 60, and 90. And that is by using a reference angle chart or by using the unit circle. We're going to learn the unit circle in the next lesson. It's the same stuff as this, just through a different lens, which is really nice. But here is the chart, and unfortunately, you're going to have to memorize this chart. So we know that from our previous page, we have actually filled all of these out. We know sine of 0 is 0, sine of 30 is 1/2, sine of 45 is root 2 over 2, 60 root 3 over 2, and sine of 90 is 1. Cos is the opposite direction. So cos of 0, is 1. Cos of 30 is root 3 over 2. and then it's the same root 2 over 2, and then 1/2 and 0. So you can see this pattern. Sine goes from 0 to 1, and it's got 1/2, root 2 over 2, and root 3 over 2. And then cos is the opposite direction. It goes from 1 to 0, and all of these values in between are in the opposite order. 2 over 2 and 1 over 2. So it's nice to see that. It gives it some sort of pattern, so memorizing it isn't as hard. And then tan is always going to be the sine divided by the x. So 0 divided by 1 is 0. 1/2 divided by root 3 over 2 is 1 over root 3, or rationalized root 3 over 3. Root 2 over 2 divided by root 2 over 2 is just 1. Root 3 over 2 divided by 1 over 2 is just going to be root 3. And 1 divided by 0 is undefined. So it tells you that here, there's two little tricks. The sine ratios increase from 0 to 1. The cos ratios decrease from 1 to 0. The tan ratio are always equal to the sine ratios divided by the cos ratios. So why are we doing this? How are we using it? Well, we can use this to write. So it says here, we can use the previous table together with the concept of reference angles and the cast rule to determine the exact values of the trigonomic ratios of certain angles in quadrant 2, 3, and 4. So it says, write the following in terms of a reference angle and determine the exact value. So sine of 210. So let's do a little sketch. 210 degrees right here. So that's quadrant 3. And that is a reference angle of, what do we got? Well, 210 minus 180, that's weird, is equal to 30 degrees. So our reference angle is 30 degrees. And in add sugar to coffee. So we know that sine ratio will be a negative value because it's in the third quadrant. So we know that sine of 210 should be the exact same as negative sine of our reference angle 30. And if we go to our chart, we'll carry that negative through. If we go to our chart, sine of 30 is 1/2. So the answer is going to be negative 1/2. Let's do the same thing with the cos of 300. So cos of 300 is going to give us some angle here, and we're looking for that reference angle. So this is our rotation angle. This is our reference angle. So we are in Q4. We know that cos will be positive. Cos ratio will be positive. Our reference angle is 360 minus 300, which is equal to 60 degrees. So now that we know the reference angle and the fact that it's going to be positive, we can say that, well, we know cos of 300 is going to be the same as cos of 60. That's its reference angle. And cos of 60, if we go to our chart, is going to be 1/2. All right, next one, tan of 225. Actually, you know what? I'll leave that one for you to try. So try it out, see what happens. Look for the reference angle, look for what quadrant it is in to figure out if it's positive or negative, and then use your chart to figure it out. I'm going to move on here. Okay. Without using technology, determine the exact values of theta, where cos theta is equal to negative 3 over root 3 over 2 between 0 and 360. So our cos value is negative. So let's look through here. All add sugar to coffee. So a negative cos value means we are going to be in quadrant 2 and quadrant 3. And we need to figure out, okay, well, cos of root 3 over 2. Cos of root 3 over 2 is 30 degrees, right? So that means our reference angle is 30 degrees. And we're in quadrant 2 and 3. So 30 and 30, which means that our rotation angles, so this is what we're looking for, is the rotation angles are going to be this one and that one. So we are going to get theta is equal to 180 minus 30 and 180 plus 30. So we get theta is equal to 150 and 210. There we go. Tan theta is undefined between 0 and 360. So undefined means that we have a reference angle of 90 degrees. Add sugar to coffee. So a reference angle of 90 degrees in both quadrants 1 and 3 is going to be right there and right there. If you did the other quadrants, because it doesn't specifically tell us whether it's a positive or negative, it's just undefined, you'll see that you will get the same thing, right? So if you're looking in quadrant 2, let's do it in blue. It's going to be right there, right 90 degrees from there, and in quadrant 4, 90 degrees from here. It will still get us that same line. So reference angle of 90, which means that we are looking at, well, 90, and this one down here is 270. That one's nice and straightforward. Last example here, the point -3, I don't know what's happening, go away. The point -3 root 3 is on the terminal arm of an angle theta. Without using technology, complete the following questions. So we can do a quick sketch here. So if this is x and y, we know x is negative, so we're going towards the negative, 1, 2, 3, somewhere over here. And y is going positively root 3, which won't be as far as 3. Root 3 isn't as big as 3, so let's say something like that. And this is point P, which is -3 root 3. And we are looking for this angle. So draw the angle in standard position and mark the point P. We've done that. Perfect. State the values of x and y. Well, we know that x is -3 and y is root 3. So x is -3, y is root 3, and we are looking for the value of tan theta. So tan theta is equal to y over x. So in this case, root 3 over -3. Or we can pop that negative into the top. State the reference angle and hence the rotation angle. So we have to look up negative root 3 over 3, or just root 3 over 3 for tan. So if we come up here and tan, here it is right here, negative root 3 over 3. So our reference angle is 30. Reference angle is 30 degrees. And that means our rotation angle, if this one is 30, then our rotation angle is 180 minus 30, which gives us 150 degrees. The more that you use that table, the easier it is to memorize it. And we'll spend some time on that. Thanks for watching. Don't forget to like and subscribe.